What's up, guys? Today we're going to be looking at 4.4 where we're going to be comparing functions. We're going to compare properties of two functions represented in different ways. So let's go ahead and jump into it. But before that, our daily funny, if only it were this easy. If any of you write that on a test or a quiz, by the way, I will count it wrong. I'll laugh, but I'll count it wrong. Okay, comparing rates of change of linear functions says which function has the greater rate of change. Remember, rate of change is slope. And if you remember, slope is the change in y over the change in x, or the whole idea of rise over run, vertical change over horizontal change. So if I'm looking at this one right here, the slope is my rate of change. So this is the rate of change of the first one. This one I'm not given it as easily, so I have to find that. So what I need to do is I'll find the difference of a couple y values and then find the difference of a couple x values. Remember, it doesn't matter which y value you use and even what order, as long as you're matching it with the x value in the exact same order. So that part does matter. So I'll just do 5 minus 8. And I'll put that over 1 minus 2. 5 minus 8 is negative 3. 1 minus 2 is negative 1. A negative over negative is a positive. So I get a slope of 3. Says which function has the greater rate of change? Well, this one has a slope or a rate of change of 4. So the greater rate of change is 4. So you'd say this one. And you maybe write that out, 4x plus 2 has the greater rate of change. Pretty straightforward, not too difficult on that. Here is one for you to try, so go ahead and pause the video. The answer will be up in 3, 2, 1. And there you go. There is your greater rate of change right there with the 4. All right, next thing, it says comparing initial values of linear functions. Says the key is trying to decide what baseball camp to attend for each camp. The relationship between the number of days and the total cost is linear. Which camp has the greater initial cost? An initial cost is going to be what you pay no matter what. Okay, so it is a fee-based thing. So the way that we'd work through this is, first of all, this one, the initial cost is going to be $89. All right, so pretty straightforward right there. Okay, the initial cost on this one is $89. And then for this one, we have to do a little bit of figuring, and this is where it gets a little bit more difficult. Okay, so we're going to say that these are our y values, and these are our x values, and we have to use these to find slopes. So difference in y, so 121 minus 236 over 2 minus 7 equals negative 115 over negative 5 for a slope of 23. Which means you pay $23 per day. The next thing is we got to find out what that initial cost is. So we're going to use the slope-intercept form, which we've talked about this year, is y equals mx plus b. And I'm going to substitute values into this from what I know from this particular problem. So I need a y value. Well, right here's a y value. 121 equals, and that's 121 with a slope of 23 and an x value of 2. So when x is 2, I get this. All right, when x is 2, it's 2 times 23 equals 121. And then this is going to give me that b value, which right here is the initial value, okay, or the initial cost. So then I work through this and I get 121 minus 23 times 2, which is 46. So 121 minus 46 is going to equal b. And the b on this one equals 75. So the initial value on this one is 75. Now that's kind of confusing. You're going to have to really work through those kind of things. That's difficult. Okay, but this one right here is the greater initial cost, and that's using the slope-intercept form. We'll spend a few days on class on working through these, so don't get too overwhelmed with this. But here, you find the slope first. After you find the slope, you find the y-intercept by substituting in the slope and 2 of your coordinates into y equals mx plus b. Here's one for you to try, so go ahead and pause and give that one a go. The answer will be up in 3, 2, 1. And there you go. Steve's has the greater initial value, and this one is similar. You're finding slope, then you have to find the y-intercept. So take your time, check this work against your own. All right, comparing nonlinear functions. It says Jack and Manny each have a savings account. The graph represents Jack's account. Manny deposited $500 and withdrew $20 each even-numbered day for 30 days. Compare the functions. Okay, so first thing is for Jack's account, the best way to compare is to make a table. So we have Jack, and then we have Manny. For Jack's goes up, and then it goes down, and then it goes up. Okay, so his increases and decreases. Manny's, if he's taking out $20 every day, then his only decreases. Another way that we could compare this is that this one is not continuous. Notice it goes up and then down and all around in every which direction. If Manny is taking out $20 every other day, then that is continuous, which means it's the same thing every single time over and over and over. And this one is not continuous, or it's not the same thing over and over and over. And then the next thing is to think about the greatest values and the smallest values. So we're just some different things to compare. For Jack's, we could look at the thing. The smallest amount he has in there was 100. The greatest was 400. So we'd say his minimum amount is 400. And the max is what? That should be 100. The max is 400. For Manny, his max was 500. So that's what he starts with. And then his minimum is going to be, he's taking out $20 for 30 days. So that's 15 times because it's even number days. So 15 times 20 is 300. So 500 minus 300 is a minimum of $200. All right, and you may need to write that out and work it out, and that's perfectly fine. But this is just some ways that you could compare these functions. You know, how do they look compared to one another? So here's one for you to take a look at and compare. Go ahead and pause and try this. The answer will be up in 3, 2, 1. And here you go. So Jack's would all be the same. Vikram, his only increases. It's continuous because it's the same thing every time. Is a minimum of 150, and then two week periods or 4 weeks go by, so he deposits its 150 twice for a max of $450. All right, comparing proportional functions. It says Arama and Francisco trained for bicycle races. The graph represents the distance Arama traveled during today's training session. Francisco's distance is given by the function d equals 18.5. Where d represents distance in miles and t represents time. Who traveled at the faster rate? So again, we're comparing slope. Here is the slope of Francisco. Arama's is going to be the slope that's given by this slope triangle. And here we have a couple points that we could use. So I go from 10 to 50 is 40. And then I go from 0.5 to 2.5. So I go over 1, 2. So that is 40 divided by 2, which equals 20. So there is the speed, or the rate, of Arama versus the rate of Francisco. So Arama traveled faster. Here's one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. And here's this one. So Jala's card house is built at a rate of 2 number of levels per minute. And Caleb's was 3.5 or 1 or 3 halves or 1.5. So Jala or however you say it, they are the one with the faster rate. That's it for today. So hopefully you took good notes. See you in class.